Okay, so this one, we have to be smart. This graph is going to tell us a lot of stuff. This function is going to tell us a lot of stuff. I'm going to be honest. When I want to graph it, I definitely, the easiest. I want to start with the easiest. The y-intercept. The y-intercept, if I plug in 0, I get 7. Bam. Right there. Axis of symmetry. Graph the parabola. I'm not sure yet. I'm going to do the axis of symmetry first. Because that's pretty easy. X equals negative b over 2a. So I'm going to get 6 over 2, which is 3. So x equals 3. Then you know what? I'm going to plug in 3. I'm going to get 9 minus 6 times 3 plus 7. I get 9 minus 18 plus 7. You know what? I think this is familiar. Pretty sure it's the same as the one we did earlier. But I'm going to be honest. If it's not, I need to make sure I don't just be like, oh, that's just like the other one. So I've got 3, negative 2. Here is my axis of symmetry. Now I need to find the x-intercepts. Now I could plug in a bunch of values and just see what happens. But what if I don't get x-intercepts, right? So if I plug in 4 and 5 and I don't get like 4, 0 or 5, 0 or something like that, I'm going to have to backtrack. So I'm just going to find the x-intercepts. Maybe I luck out, and that was it. But let's see. What if I factor? Because that's the easiest method. I get x minus, I get 7, negative 6, 1 and 7. It's not factorable. If it was factorable, I could easily find the x-intercepts and blah, blah, blah. So it's not factorable. I can't find any numbers, right, that's going to work. Because if I have 7 and negative 6, I have 1 and 7. Because it's negative 6, this would be have to be negative. And if that's negative, this would have to be negative, and it's not. So it's not factorable. So the only way I can find the x-intercepts easily, because this is 1 and this is even, I could complete the square. But I'm going to be honest, I just don't usually go that route. You're welcome to do that route if you want. But I'm just going to go x equals negative b plus or minus square root of b squared minus 4ac all over 2a, which is positive 6 plus or minus 36 minus 4 times 1 times 7 all over 2 times 1, which is 6 plus or minus 36 minus 28 over 2, which is 6 plus or minus 8 all over 2, which is 6 plus or minus 2 radical 2 over 2, which is 3 plus or minus radical 2. And then I would honestly take my calculator right there. So 3 plus radical 2 is about 4.414, blah, blah, blah. So if I plug in, 4.4. So there's 4, there's 4.5, so it's somewhere around here. It's a little less than 4.5. And if I go 6 minus, 3 minus radical 2, I get 1.4 ... Just fine. So it's a little less than 1.5. And that's going to give me enough to graph. Honestly, I don't care too much about, and I'm going to get, 1, 2, 3, 1, 2, 3. Bam. put arrows. Oops. So that's going to give me enough. X-intercepts. So I'm going to say, what was it? 3 plus or minus radical 2. I'm going to leave it like that. X-intercepts. I'm going to go 3 plus or minus radical 2, comma 0. And, you know what? Let's make it 3 plus and 3 minus radical 2. That way it's a perfect number. It's not an estimation. If you estimate it, it's not going to be a big deal, but that's good enough. Interval of increasing. So it's increasing from 3 to infinity. And see how I notice I don't put the parentheses or brackets until the end. Increasing, so it's got to be a parentheses. And infinity has to be a parentheses. Decreasing from negative infinity to 3. And again, parentheses. Does it have a max or min? It's a min. Domain. Well, the domain is the x values. So my x values, I'm just looking at these numbers here. And it's going to go all the way, because of that arrow, it's going to go all the way from negative infinity to positive infinity. And the range is going to go from here up. So starting at negative 2 to infinity, and it includes negative 2.